Thank you. Thank you for inviting me to speak today about my research and how it's being impacted by the current administration. I was asked to talk about my research and funding from the perspective of an academic scientist. First, a bit about me. I grew up in Queens, and I realized at an early age that I wanted to be a scientist. Whether chasing butterflies in Alley Pond Park or looking at my own cells through the microscope, I was interested in understanding human health and how we could better our efforts in that direction. It wasn't until I was in college, though, when I became a vegetarian, and this was the 70s when that was a thing to do, that I realized how important nutrition was. And I realized that nutrition science was going to be my career direction. And I studied the role of nutrition in relation to chronic disease, cancer, dementia, metabolism. My work is lab-based, and I focus on the cellular and molecular mechanisms by which vitamins function. It's interesting that the mayor mentioned the sister studies, because in the sister study we have actually found evidence that vitamins, in particular vitamin D, the vitamin that I've been studying for 30 years, is important in protection against breast cancer. So in my 30 years of continuous funding from the federal government, I've been awarded grants from the National Institutes of Health, the Congressionally Directed Medically Research Program, the United States Department of Agriculture, and others. I have received a lot of money. So what is it used for? Number one, I would say it's used for people. The most important ingredient in a research lab is its people, ranging from undergrads to graduate students to postdoctoral fellows to research associates, and supported by technicians and lab managers. I have one research associate who has been working in my lab for 30 years. She has been funded through my grants from the NIH. This is the memory of my lab. This is the way my lab can move things forward, having people long-term that know the experiments we've done and know the direction we need to go in for the next step. In this 40 plus years that I have been an academic scientist, I have personally trained 20 graduate students, mostly doctoral students, 10 postgraduate fellows. And all of these trainees have gone on to positions in academia, in government labs, in the pharmaceutical industry, and in public health. So while universities may provide some funding for graduate students, the vast majority are supported on research grants. And all of these positions are in jeopardy as grant funding declines. Fellows and research associates and technicians are exclusively funded by grants. There is little to no backup when funding declines, as is currently in jeopardy. Make no mistake, people will be let go. Not only does the research project suffer, but the loss of the academic lab training pipeline will lead to a huge gap in trained scientists for the foreseeable future. So people is number one. Number two is supplies and equipment. All grants that we write include a budget where specific items necessary for conducting the proposed research are listed. And some grants require specialized equipment, which is very, very expensive. It's dedicated to that project. Others request core equipment that teams within the university will use. These large equipment facilities typically require specialized personnel, and they also serve as training resources. And like an iPhone or a TV, scientific equipment is constantly improving and needs to be updated frequently. Universities have limited funds to support the purchase and operation of this expensive equipment. And for example, the major research instrumentation grants that we can get from NSF and NIH are designated for purchase of equipment costing between $2 to $4 million. So this is very expensive and has to be supported by research grants. A third area that grants fund is conferences. For the past 10 years, I have received funds in the form of an NIH conference grant in support of an international scientific conference on the biology and health implications of vitamin D. NIH-funded conferences like this serve as networking hubs for collaboration, as well as dissemination of the results of our funded research. And this leads to policy decisions and population recommendations, particularly in the case of nutrition research. And the fourth area is the indirect costs that have been mentioned. These indirect costs were abruptly and drastically cut by DOGE over so many unseen costs of the research. Examples include the facilities, the lights, the utilities, the building upkeep, and grant administration like purchasing and HR and financial tracking of grant monies, safety procedures and training, compliance issues and regulations, disposal of biohazardous waste, etc. And each university negotiates these costs based on their specific situation. So it's important to note, finally, that universities provide the infrastructure, such as this beautiful e-tech building, but the labs would be silent and empty without federal funding. Funding from non-governmental organizations and private foundation is out there, but it's nowhere near the scope of what the federal government can provide. And sadly, the uncertainty and unpredictability of the current federal government is making many established researchers and aspiring trainees rethink their career choices. My current funded grant on vitamin K and breast cancer has been cut by $50,000 due to the continuing resolution. I submitted a new grant on nutrients and dementia last week, but I'm not certain of the timeline for it to be reviewed or funded. The biggest danger of these policies is the collapse of academic research and training, ultimately damaging the future ability of the U.S. to compete globally in science and innovation. Thank you.